So let's talk about general organic chemistry. Now, in general organic chemistry, first of all, let's consider a covalent bond. A covalent bond is here. A is forming a bond. B. We know there are three types of bond. Okay, we know there are covalent bond. There is a covalent bond. There is a coordinate bond. There is a covalent bond. There is a coordinate bond, and there is a ionic bond. There is a ionic bond. We know covalent bond is formed by sharing of electron. It is formed by sharing of electron. Coordinate bond is also formed by sharing of lone pair. Sharing of lone pair. An ionic bond is formed by transfer. Transferring of electron. It is formed by transfer. When electrons are transferred from one atom to another atom, then ionic bond takes place. Now we talk about covalent bond. In general organic chemistry, the most of the compound are formed by carbon. Carbon forms covalent bond. It generally forms covalent bond. So we will be studying about covalent bond. Now if we talk about A is forming B, A is forming a covalent bond with B by sharing of electron. Now if we try to break the bond, okay. Now if we talk about bond fusion, if we talk about bond fusion, no bond fusion, not it. If we talk about bond fission, if we talk about bond fission, if we talk about bond fission, so bond fission takes place in two categories. One is homolytic bond fission and one is hydrolytic bond fission. One is homolytic bond fission and one is heterolytic bond fission. Heterolytic bond fission. One is homolytic bond fission and one is heterolytic bond fission. Okay, homolytic bond fission is named as homolysis. Heterolytic bond fission is named as heterolysis. Homolytic bond fission is named as homolysis. Heterolytic bond fission is named as heterolysis. Okay, so now if we share further, if we talk further, now there are one more type of bond fission. Okay, when if we talk about homolytic bond fission, okay, there is a formation of, if we talk about homolysis, and if we talk about heterolysis. If we talk about homolysis and heterolysis, okay, in homolysis there is a formation of free radical. When carbon is forming bond with carbon and you break in between, so there is a formation of free radical. Now in heterolysis, if you break a bond carbon with X, so if X is more electronegative, X is more electronegative, then electron will shift towards X. Then it will be formation of carbocation and X minus. So it will be formation of carbocation. And if X is less electronegative, see X. If X is less electronegative than carbon, then this bond will shift toward this. Okay, so now there is a formation of carbon anion and X positive. So there will be a formation of carbon anion. So in homolytic bond fission, there is heterolysis, there is a formation of carbocation. There could be formation of carbon ion. But in homolysis bond fission, there could be formation of free radical only. Okay. So if we categorize, homolysis is a bond breaking in which atom gets its original contribution. Okay. In homolysis, atom gets its original contribution. whatever the contributed initially, it will get the original contribution. Okay, now here it depends where in the formation of carbon and carbon according according to its electronegativity. There is a formation of carbocation and carbocation according to its electronegativity. In homolysis and heterolysis, in homolysis there is a formation of free radical. Atom gets its original contribution. Now here atom do not get its original contribution, it get contribution according to electronegativity difference. Okay, now homolysis found is non-polar solvent and it is present in light. Okay, homolysis we generally find in non-polar solvent. When solvent is non-polar solvent, when it is a non-polar solvent and light is there, and in presence of light, when light is present, h nu you have given h nu is the energy of light. Okay, it is quantized, light energy is quantized. Okay, you have already seen in atomic structure the light is quantized, the energy packets in form of h nu. So whenever light is given, the homolysis is there. Okay, so now here there is no electronegative difference, the electronegative difference is 0, and here the electronegative difference between atoms in is non-zero. So now we know that that's how there is a bond in organic in general organic chemistry. If we talk about that bond fission, okay, A and bond B, it is the basic of general organic chemistry. So how the bond could be break, how the bond could be formed. Okay, for the reaction happening, the bond, for the reaction to be proceed, the bond should be break and bond should be formed. Okay, that's why it is covalent bond, coordinate bond, and ionic bond. So now if we see further, when there is a bond, A is forming bond B. So now there is a lot of influence in bond. Influences in bond. There is a lot of influences in bond. So how these influences are there? When there is a sigma bond, or if we take a pi bond, how the bond is influenced, how it is influenced, whether it is influenced by A and B, that influence we known as electronic displacement effect. Electronic displacement that is known as electronic displacement effect. Now electronic displacement effect is categorized into two parts and categorized into four parts. Okay, one is inductive effect, one is inductive effect, second is mesomeric effect or resonance effect. Mesomeric effect or resonance effect. Third is hyperconjugation. And fourth is electromeric effect. Okay, now if we categorize this further, there are four type of effect which by which the bond between A and B is influenced. Okay, the bond, that electron cloud. Okay, that electron cloud is influenced. Now there is a very good term how electron cloud is there. When there is a carbon having a sharing of two electrons, now how we call it electron cloud? Why we call it electron cloud? When there is only presence of two electron. So now if these two electron moves so fast, it moves so fast that when you click a picture you see a cloud. Okay, so by which that cloud is displaced is being categorized into four parts. Okay, inductive effect, mesomeric effect, resonance, and hyperconjugation. Now these three are permanent effect. permanent effect, and this is a temporary effect. This is a temporary effect. So this is a permanent effect and this is a temporary effect. So in permanent effect it is been 1, 2, 3. Inductive effect, mesomeric and hyperconjugation. Now in temporary effect there is an electromagnetic. Now what is permanent effect? What is temporary effect? The permanent effect which doesn't affect by the permanent effect, that effect which doesn't affect by which doesn't affect by solvent present. Electromagnetic effect is the effect which effect by solvent present. Presence of solvent. Presence of solvent. Inductive effect and mesomeric effect are different, and it is affected by solvent present. Okay, that is which doesn't affect by solvent present is permanent effect, and electron which is affected by solvent, or we can say outer conditions or outer conditions, like if we convert into gas, it will be the gas, if it is gas, then what type of gas is there in outermost area. Okay, so that is the permanent effect, and that is inductive effect.